Well, today we are going to talk about the condenser battery. The function of the condenser battery is twofold. First, at the refrigerant gas level, it condenses it, passing it from the hot gas discharge from the compressor to a cooler liquid that can enter the expansion valve. Let's remember that the expansion valve always needs to have liquids. It doesn't like gases, so it will have sensible heat because it cools down. On. Latent heat because it undergoes a phase change. At the air level, it heats it in a sensible way. It does nothing else. This heat will be used if we are in heating mode or dissipated into the atmosphere if we are working in cooling mode. If you don't remember the concepts of sensible heat and latent heat well, you can watch a video explaining it on KEYTER Academy. At the air level, when relatively cold or cool air from the atmosphere passes through the battery, it undergoes heating as a result of the interaction, causing an increase in temperature. From a metric perspective, it is represented as the initial air temperature of, for instance, 27 degrees, which increases to 45 degrees as the air passes through the battery and gets heated up. The transition from A to B is accomplished in a sensible manner due to the fact that the quantity, absolute humidity, or specific humidity at point A is equivalent to that at point B. There has been no dehumidification, so there has been no phase change. It was air and continues to be air. Water has not disappeared, so there is no latent heat at any time, and all the heat transfer is done in a sensible way. If you do not remember these concepts well, you can also find a manual on psychrometry on KEYTER Academy. So, how do we work with the refrigerant substance in this process? In this Mollier diagram, we see that after compression, we have a mass of hot gas at high pressure that we must convert into liquid at a lower temperature. But it is important that it is liquid so that it can work correctly when passing through the expansion valve. If you also do not remember well how the Mollier diagram works, you can find a manual on KEYTER Academy. We have mentioned that after the compressor, we have a mass of hot gas at high pressure. Let's take a closer look at it now in more detail. What is our objective? To convert all of it into liquid form in order to ensure the proper functioning of the expansion valve. How do we do that? Well, we start with that high pressure gas, and the first thing we are going to do is cool it down, because there is no phase change here. From gas to this point, it's always gas. So it will be a sensible exchange, only its temperature changes. In our current process, we are actively working on cooling it down, and at that precise moment, we will observe the initial formation of a droplet of condensed refrigerant gas as we continue to lower the enthalpy. Due to the phase change, the temperature remains constant as the gas undergoes a transformation into a liquid state, resulting in a loss of enthalpy. As we make further progress, a greater amount of liquid refrigerant becomes visible, while the quantity of gaseous refrigerant gradually decreases until nearly all of it has transformed into a liquid state, making it fully prepared to pass through the expansion valve. To ensure that the valve always has an ample supply of liquid, we incorporate a safety margin by reducing the temperature of the liquid. This crucial process, known as subcooling, is vital for the proper functioning of the expansion valve. The condenser battery not only condenses the refrigerant, but also subcools the liquid to guarantee that it remains in a solid liquid form. These two functions are of utmost importance for the condenser at the gas level. We eagerly anticipate reconnecting with you in our upcoming video. Warm regards and best wishes to all.